So 5.2, we're going to talk about 5.2 today as well as on Monday. These will take a little bit longer. They're a little trickier. Okay, so we're going to spend 2 days on it. We're going to get through as much as we can today. As long as we're doing it well. And then on Monday, if we need to do a few more note examples, then we will. And then we will also be doing some kind of activity or practice or something. I haven't quite decided how I want to do it yet, but we'll spend 2 days on this. So substitution in math. Can anyone tell me what it means if you substitute something? Replace, right? Okay, replace, that's a good word for it. What else? What does it mean? What do we do when we substitute something? We replace it, but what does that mean? Okay, so maybe like replace a variable with a number. Okay, oh, I like that. Parentheses, we normally use parentheses when we substitute. Yeah, and we replace things. Basically, substituting is plugging something in for something else, right? Replacing it with a different value. So we're going to use that strategy today to solve some systems. So solving a system of linear equations by substitutions. It is a 3-step process. If you are someone that likes color coding, this is a really great color coding lesson, so you can always highlight or use different colored pens or whatever you want with that. So step 1 is to solve one of the equations for one of the variables. Now, what that actually means is make one of the equations look like an x equals or a y equals. We're not actually putting anything in these blanks here. This is just saying that one of your equations, in order for substitution to work, one of your equations either needs to say x equals or y equals. It needs to be all by itself on the left-hand side, just either the x or the y. Any x equals whatever the rest of the equation is. We're not putting anything in the blank. So maybe x equals 2. Maybe x equals y minus 3. Yep, anything. It just, all this is saying is that in order to start this problem, you either have to have x by itself on the left or y by itself on the left. Okay? And I'll show you more what that would look like in just a second. Step 2 is to substitute the expression from step 1 into the other equation and solve for the other variable. So normally we plug a number in, we substitute in a number. This time we're going to be taking an equation or an expression, so maybe some variables, and plugging it into something else. Step 3 is to plug the number or substitute the number. Substitute the number from step 2 into one of the original equations and solve. So first thing, make sure one of your equations has an x equals or a y equals. Step 2, you plug one equation into the other. And step 3 then, we take our new number and we plug it in again. You'll see the process in just a second. So just like when we graphed our lines could cross, we had one answer. You could graph and the lines never intersect, right? They're parallel, then there's no solution. Or one lies perfectly on top of the other, and that's infinitely many solutions. That can happen too when we substitute. Just like when we solve a normal equation, if you go through and you solve an equation and you get x equals 2, right? That's an answer. You get an actual physical number. So if you have one solution, x and y are going to equal a number. You're going to be able to get numbers for x and numbers for y. If we have no solution, remember when we would solve equations, if you ended up with something that didn't work, right? Like 0 equals 5, that was no solution. Same idea here. No solution means you're going to get something equals something else that just doesn't work, like 0 equals 5 or 2 equals -2. Okay, you're going to get something that does not work. And infinitely many, does anyone remember what we would end up if it was infinitely many? Yeah, something that actually makes sense, a true statement like 0 equals 0 or 5 equals 5. So we are going to practice this. If anyone is a fan of highlighting, this could be good. Does anyone want to borrow a highlighter? You want to borrow? Anyone else want to borrow a highlighter? You don't have to. When you're done with it, all right. So, solve the system of linear equations by substitution. If the system has a solution, write it as a coordinate pair or a coordinate point, like parentheses, x, y, like a point. Okay. So we have y equals -4x minus 7 and y equals 5x minus 7. Step 1 was to check and see if one of the equations was an x equals or a y equals. Well, in this situation, aren't both of them y equals? Doesn't this first equation have a y all by itself on the left? Doesn't the second equation have a y all by itself on the left? So these actually are both meeting that requirement. They're both y equals. So then the question is, well, what do we substitute? Well, when you solve with this strategy, you literally take an equation and you plug it in inside another equation. Okay. So when they're both y equals, you can kind of pick whichever one you prefer. What we're going to do here is, see how this top equation says y equals -4x minus 7? What you're going to do is take what one equation equals and plug it in the letter that matches in the other. So here I know that y equals -4x minus 7. That's what y equals. Well, if you take a look at the bottom equation, we also know that y equals 5x minus 7. Don't they both equal y? Right? So here's what we're going to do. We have y equals this. Well, down here, don't we have a y on the left? What we're going to do is we are going to take -4x minus 7, and we are going to substitute it in for y on the other side here. It takes a couple of them to get the hang of it. So they're both y equals. So what we're going to do is take what one of them equals, and you're literally just going to put it on the other side here. So what we're going to do, remember yesterday when we did our parentheses? In this bottom equation, we're going to replace y. So here's what we're going to do. On the left, I want you to put a nice big open set of parentheses. Leave yourself room because you're going to have to write a few things in it. Parentheses equals 5x minus 7. Okay. Now, yesterday we took a number and we plugged it in, right? But I don't have just one number here. I have a whole expression, -4x minus 7. So what you're going to do is take that and plug it into your parentheses on the left. So I'm physically taking the one equation and putting it in on the left on the other equation. Okay. Now, on the left here, those parentheses, is there anything I can do inside of them yet? Don't I have x's and I have y's and everything? Okay, so the parentheses were just there so you guys could see what we're plugging in where. Now all we actually have to do is solve this equation. Do you guys remember when we did the 2-column method? That's what we're going to do. This is set up exactly the way we need it. We are now just going to do the 2-column method. Now I know that this is very tricky the first couple times, so just bear with me for the first one, okay? And then the same things tend to happen. Are we paying any attention? Jaden, I don't think this is something you can sleep through and understand. I'm going to be honest with you. All right. Do you want to go to the nurse? You sure? Yeah? Okay. All right, go past 1 second. Oh. I wrote the date in the wrong place. That's okay. There you go. Okay, so let's do our 2-column method. Pay attention. Negative 4x, should that stay or go? Stay. So negative 4x is going to stay. What about the negative 7 on the left here? Go and become a positive. All right, now on the other side, what about the 5x? Goes and becomes negative. Were you just going to answer, Jake? Okay. Goes and becomes negative. And then what about the negative 7 that's on the right? Stays. Okay. So now let's simplify. What is negative 4x minus 5x? Negative 9x. Good. Negative 9x equals, and what's 7 minus 7? 0. What would my next step be? Divide both sides by negative 9. And what is 0 divided by anything? Just 0. X equals 0. And that's okay. 0 is a number. 0 is allowed to happen. All right. Now, this part's going to be more similar to what we did yesterday. We now know what X is, but we need an X and we need a Y. So now what we're going to do is we know X equals 0. You can now pick either of the top equations and you're going to plug 0 in where you see it X. So if you take a look maybe at this second equation here, isn't there an X right here? So we can now take that X and replace it with the number 0. So this is more like what we did yesterday. So what we're going to do is I'm going to write my second equation here. We had y equals 5x minus 7. But we now know that x equals what number? 0. So we're going to take this and we're going to rewrite this with our blank set of parentheses. 5 times some number minus 7. What number are we going to plug into those parentheses there? 0, because that's what we just found out that it equals. So we're going to plug in our 0, and now we're going to just follow our order of operations. What's 5 times 0? 0. Anything times 0 is just 0. What's 0 minus 7? No, you're thinking multiplying. If you have 0 and you take away negative 7, you're at negative 7. Yeah. So 0 minus 7 is just negative 7. Oh, I didn't need to box that. My bad. Okay. Y equals negative 7. Now, girls. Okay. So now the question is, how do you write your final answer? Well, yesterday, weren't we graphing them and seeing where they crossed? This is just another strategy for that. All you got to now do is take your two numbers and write it as a point in parentheses. Yeah, 0, negative 7. And that's your answer. Right. I know, it's going to take a couple to get used to it, Dallas. These ones are tricky. That's why we're going to spend 2 days on it. All right. All right, so now let's try this again. Again, I know that this is tricky. Just bear with me for a couple of them. Do we have this all copied down over here? Okay. So let's go to 2. Now, if you look at number 2, very similar. We got y. Yes, Asia. No, you're fine. So the first
one that we did,
does
it have to, well, does it have to have like the same numbers at the end? Or like,
I don't understand your question.
They both have like the -7 on the end of them. Does it have to be the same number?
Oh, no. It's just, basically what we're doing here, Asia, they both equal y. So you just set them equal to each other. So like in this situation here, for number 2, don't these both equal y? If they both equal y, then what you can do is bring this top equation down and plug it into the bottom one. If they both equal y, if 2 things equal the same thing, right? 2 things equal 5. Aren't they equal? Right? If they equal the same number, right? They're equal. So in this situation, pretend y is a number. Pretend y is 2. If they both equal 2, then aren't they the same? In math, if things are the same, can you set them equal to each other? So what we're going to do here is these both equal y, so they equal each other. So again, follow my process again. This top equation, you have y equals -6x minus 8, right? That's what y equals. Where do you guys see a y in the second equation? On the left, right? So what we're going to do is we're going to take this top equation and we're going to plug it in where y is on the left. Okay, there you go. There you go, Brooklyn. What'd you write down? Tell me again. It was correct. -6x minus 8 equals -6x plus 7. Exactly. That's exactly how you write it. You take the 1 and you just plug it in on the left. Take the 1, plug it in on the left. What do? We take the 1 and we plug it in on the left. Okay? So now can we do our 2-column method? Yes. All right. So put your 2 columns. Yeah, -6x is going to stay. What about the -8? It's going to go and become a positive. Now we're on the other side. What about the other -6x? Go and become positive. And then the -7 or the +7's already on the correct side, so it is going to stay. Okay. Ladies and gentlemen, if I have -6x and a +6x, what is going to happen? They are gonna combine and become what number, Hayden? 0. Don't they cancel each other out? Yeah. So are there any x's left over on the left? There's none, right? They completely cancel each other out, and on the left we're gonna just have 0. Well, no, and then on the right we're gonna have what number, Asia? 15, because 8 plus 7 is 15. Now, does 0 equal 15? Lynn, are you paying attention to your drawing? This is just tricky. I want to make sure that you're following along. So does 0 equal 15? No. So if you get something that is not true, what do we say? No solution. And then you're done. You don't even have to go on to the next step with this one because there is nowhere to go. Right, you can't, there's nothing to plug in. You got no numbers, you're done. That's it. Corey, you awake over there? All right, last one of this kind. And we are going to practice this more on Monday, okay? Because this is not the easiest thing we're going to do all year. Okay, this looks the exact same, right? Y equals -6x minus 15 and y equals -3x minus 6. If they equal the same thing, they equal each other. So what we can do, we are going to take this -6x minus 5, and where are we going to plug it in? On the left, right? We're going to take this. Well, yes, we can use parentheses if we want. But we're going to take this. It's y equals, and we're going to plug it in where we see y equals. Take it and plug it in on the left. Negative 6x minus 5, right? That's what y is. So plug it in where you see y. Yeah. Yes, negative 6x minus 15. Okay. So this is the exact same thing. Again, remember, you take what it equals, plug it in on the left. Take what y equals, plug it in on the left. So this negative 6x minus 15 is going to go on the left. And then the negative 3x minus 6 is going to stay on the right. Welcome back. Oh. Uh-oh. We'll see. We'll see you in a few weeks.
You need that temperature.
Okay, but if I go ahead and say that, it's gonna make everybody be like, oh my God. She has corona.
That's what. Yep. Well, if you get a negative test, they'll let you come back.
I'm just saying corona.
All right, so let's do our 2-column method. Negative 6x, stay or go? Stay. Bye, Jaden. Have a good weekend. Good luck. Okay, negative 6x, it stayed. What about the negative 15? Goes and becomes very good, Annalise. It's going to go and become a positive. Yes, goes and becomes a positive. And then negative 6 on the other side stays. All right. Now let's combine our like terms, ladies and gentlemen. What is negative 6x plus 3x going to give us? Plug it into your calculator if you need to. I'm not doing it for you. I am not your calculator, Olivia. Negative 3x. Honestly, we should all automatically grab calculators when we walk into class if we don't have one. No, I was talking to Olivia. 15 minus 6. I'm not your human calculator. What's 15 minus 6? 9. Then what do we do, Jake? Yeah. Divide both sides by negative 3. Yep. And 9 divided by negative 3 is negative 3. Okay. So this time we found a number that works for x, didn't we? If we can find an x, can we now use that to find y? Yes. Okay. So we now know what x equals. If you look up above, don't you see x in a couple places? So your next step then is to just take your x and plug it in either one. Any one you want. I'm going to pick the bottom one just because I've drawn on it less. Okay. So you're going to take your x, because x equals negative 3, and you're going to plug it in where you see x in one of your other equations. So this is like you're taking your value and you're plugging it in. This is like what we did at the start of class yesterday. So you have the equation y equals negative 3x minus 6, right? Isn't that one of your equations? Yes or no?
Yeah.
Yes, okay. And it has the letter x in it, doesn't it? But don't we know what x equals? So can we plug it in? Yes. So let's rewrite it with our parentheses. Y equals negative 3, parentheses minus 6. What number am I going to put in the parentheses? What does x equal? Negative 3. Corey, are you writing this down? Okay. All right, then let's simplify. Follow your order of operations. What do we do if we're following our order of operations? Very good. Multiply negative 3 times negative 3. What's negative 3 times negative 3? 9 minus 6. And what is 9 minus 6? 3. And then we write our final answer as a what? As a point. So how could I turn this into a point? Yeah, negative 3, comma 3. All right. Alrighty, number 4. All right, we are on number 4, ladies and gentlemen. Can someone tell me what looks different about number 4? Jake? Jake, what looks different? Good, yeah, there's no y equals, right? For this one, there's no y equals. Is there an x equals? Yes, so only one of them, right? So it is a little different, because in the other ones, there were 2 y equals. This time, there's only one x equals. Now, that's actually still okay. You just have to have at least one equation that has a y equals or an x equals. Now, if with the other ones, they were both y equals, so you just take one, put it on the left on the other, right? This strategy is going to be slightly different. We don't know what y equals, right? There's no y equals, but we do have an x equals, don't we? So here's what we're going to do. We're going to take this y equals, and you can highlight it, you can circle it, whatever, okay? But point it out to yourself. You got an x equals, right? So if you look at the top equation, do you guys see the letter x in the top equation? Okay, so you need to now either circle, highlight, or whatever that one. Pretend you knew that x equaled 5, right? Pretend you knew x equaled 5. If x equals 5, can't we take it and put it where you see x? Wasn't that what we just did right over here on the, right here? With the other equation, we knew what x equals, so didn't we plug it in? Well, here, don't we kind of know what x equals? Like, yeah, there's a variable in it, but pretend there's not. We know that something that x equals. So what we can do is take it and plug it in where we see x in our other equation. So what we're going to do is this top equation, we're going to rewrite it, but we're going to leave the x out. And instead of x, we're going to put a nice big open set of parentheses, just like we did over here when we plugged in a number. So we are going to rewrite this as 8, big open set of parentheses, minus 3y equals -1. Okay. Now, normally when we do this, we plug in a number, right? But I don't have a number. But don't I have a 7 minus 2y? Isn't y technically just a number? We just don't know what it is yet? Yeah, so what we're going to do is we're going to take that and plug it in for the x. We're taking the 7 minus 2y, and we're going to plug it in where we see x. So instead of x, we're going to write 7 minus 2y. It takes a couple times. It's going to be tricky the first few times. Yeah, it's going to take a few times. Okay, so pretend x just equaled a number, right? Say it was a 5. Wouldn't you take it and you plug it in where you see x? But this time it's not a number, it's what we call an expression. So we take 7 minus 2y and you plug it into the other one. It's going to take a few tries to kind of see those steps of it. Okay, yes, and now we have 8 parentheses, 7 minus 2y minus 3y equals -8. Well, isn't this just an equation? Don't we know how to solve equations? We spent a whole chapter doing it. So if you just have this equation, does anyone remember what the first step you would take is, Asia? Distribute. So let's now distribute. Yeah, we're going to do 8 times 7. What's 8 times 7? 56. And then 8 times -2y, which is going to give you what? -16y. And then drop down your minus 3y and your equals -1. 56 minus 16y, and then I just drop down my -3y and I drop down my -1. Now can't we do our 2-column method? Sorry, what, Dallas? I know these are challenging. That's why we're going to spend a couple days. Yes. Well, and this is one that it takes a couple examples before you start to get the hang of it. Okay. Yeah, he does. He picked one up yesterday. Okay, so then put your 2 columns. Okay, so now this is just solving an equation. Don't overthink this part. Does 56 stay or go? Goes. Goes, make it a negative. Okay. Negative 16y, stay or go? Stay. Negative 3y, stay. And now we're on the other side. What about that negative 1? Stays. Okay. Now combine your like terms. What's negative 16y minus 3y? Very good. Negative 19y. Negative 56 minus 1. Negative 57. Look at you. And then what do we do to both sides? Divide by negative 19. Good. Yeah, a negative divided by a negative is a positive. And then you can always plug this into your calculator. 57 divided by 19. Yeah, would give you a positive 3. Okay. So now we know what y equals, right? Okay. I'm going to erase a few things up here just because I have a lot of little lines. Okay. So we know what y equals. We'll take a look up at your two top equations. Don't they both have y's in them? Yeah, they both have y's in them. So could I take my 3 and plug it into one of those? Okay, now the question is which one? Well, I'm going to tell you. Yeah, I'm going to tell you that either of them work. Okay, you can make either of them work. One of them, though, is a little bit simpler than the other. The bottom one is more simple because, and I want to point out to you guys why. Don't we know what y equals? So if we found a y, what's the other letter we're looking for? X. If you look at this bottom equation, isn't it an x equals? That's how you know that it's a little bit easier to plug it in there. So we're going to take this 3 and we're going to plug it in where y is in the other equation. Okay, so our equation here is x equals 7 minus 2y. Okay, so I'm just rewriting that equation. And we know what y is, right? So instead of that, we're going to put our open set of parentheses, x equals 7 minus 2 parentheses. What number am I plugging into those parentheses? The 3, because that's what we found that y is. So in those parentheses, I'm going to plug in my 3. And now, can't I just simplify? Yeah, use your order of operations. What would we do first? Would we do 7 minus 2 or 2 times 3? 2 times 3. So 7 minus 2 times 3 is 6. And 7 minus 6 is 1. Okay. Again, I totally understand if you're a little like, whoa, what just happened? I think I want you to start to, these are hard the first few times you do them. It's one you got to get used to the steps. Yes, Asia.
So when I didn't take the negative with the 2, but why would it? Like, why would you do negative 2 times 3 instead of making it where it's a positive?
Oh, either way, Asia, it'll work both ways. Yes. Okay, so now we got to write our final answer as a coordinate point. How would I write that as a coordinate point? 1, 3. Okay. We're gonna hopefully get 2 more done and then practice more next time. And I think I'm gonna like try to make something online for this, like a Google thing. I don't know yet. I'm not a game, but like I'm hoping something that'll help you guys. No, definitely not a Kahoot yet. I don't know yet. All right, let's look at number 5. Number 5. All right. So step 1 is to look and see if you have an equation that's either an x equals or a y equals. Do we have that? And if we do, where is it? Do we have an equation that's an x equals or a y equals? Olivia, which one? We have a y equals. Where do you see that? on the bottom. The second equation is a y equals equation. So we know that y equals whatever. Who cares what it equals? It doesn't matter what it equals. Don't even think about what it equals. But if you know that y equals something, can you take it and plug it in somewhere else? That's what we're going to do. We know that y equals negative 4x plus 4. Don't focus too much on what it is, but it equals something, right? So if we know that y equals this thing, can we take y and plug it in the top equation? Yes or no? What do we think? Yes. Where do you guys see y in the top equation? Yeah, right here, right? Okay. Yes. So we are going to take what y equals, and we're going to plug it in place of this other y. So I need to rewrite my top equation, don't I? But instead of y, what am I going to put? So think about the steps we've done so far. First step is to figure out if you have an x equals or a y equals, right? Second step is to plug it in. But when we plug it in, what do we use? Parentheses. Okay, so think about first step, figure out if you have an x equals or a y equals. Second step, rewrite your equation with parentheses. So we're going to have negative 2x minus, and then do we want to keep that y, or are we going to change that y into something else? What do we think? Is that y? Do I want to write that y, or do I want a nice open set of parentheses? We want an open set of parentheses. Equals negative 4. Because I don't want y. Now again, I know this is super tricky, but what you want to think about, guys, is don't these problems have two variables? Do you want, when you're solving for a number, do you want two variables? You want one variable. Yeah, two variables, that's bad. That's a lot. You want one variable. We're trying to figure out how to rewrite this with just one letter. Basically, what we're doing is we're throwing y out. We don't want it. We're just going to look at the x's. So that's why instead of y, we throw it out and we just put a nice big open set of parentheses. We're going to change it into something else. We're going to change it into something we want. We're going to change it into what the bottom equation says. We're going to change this y into a negative 4x plus 4. Because doesn't that have an x in it? Doesn't the new equation we wrote have an x in it? Yeah, we only want x's. We just want x's. Just throw away the y's. So what we're going to do in this set of parentheses, who can tell me what we're going to plug in there? Good. We're going to plug in negative 4x plus 4. Good. Okay. Now, you can completely ignore the original problem. Just focus on the equation we have written here. If you needed to just solve this equation, it's chapter 1, we're solving equations, okay? What would be your first step to solve this equation? What would we distribute? Oops, sorry, I don't know what I just did. Yeah, so what we want to subtract those, but if you look, Dallas, isn't this in parentheses here? So when it's in parentheses, we always want to check for distributing. Huh? Oh, no, that's okay. I think you're just thinking we want to combine our like terms, but if you look, this one's a little weird because if you look in front of the parentheses here, Dallas, isn't there a negative sign? So technically, if there's a negative sign, what number is there? A negative 1. Yeah, it's technically it's invisible, but there's technically a little negative 1 in front of there. So we're going to first distribute our negative 1. Okay, so do we want to do anything with the negative 2x yet? No, we're just going to drop it down. We're just going to bring it down. We can't do anything with it yet. Oops, sorry. So just bring it down. Okay, now we're going to distribute our negative 1. What is negative 1 times negative 4x? A negative times a negative is a positive 4x. Okay. Negative 1 times positive 4 is? Negative 1 times positive 4. It'd be negative 4. Equals, and then drop down your other negative 4. Now can we do our 2-column method? Yes. Okay. So 2 columns, negative 2x, should it stay or go? Stays. And people at home, you can chime in too. Positive 4x, stay or go? Stays. What about this first negative 4? Good, yeah, it's going to go and become positive. And what about our other negative 4? Stays, and it stays negative, right? All right. So now let's combine our like terms. Negative 2x plus 4x. Negative 2x plus 4x. It is going to go, that'd be if they were both positive. Negative 2 plus 4. I'm not your human calculator. Negative 2 plus 4, Corey. 2x. Good. And then 4 minus 4 is 0. Thank you. All right. What's our next step? Divide by 2. Okay. And what is 0 divided by 2? No, you were right. 0 divided by anything is just 0. All right. Now we know what x is, right? If we know what x is, what letter do we still need to find? Y. We still need to find y. Well, look at your original, all your original stuff up there. Isn't one of them a y equals? Yeah. So what you're going to do, our next step here, is to take the number we found and to plug it in to either one of these original equations. Which one looks like a good place to plug in an x? The top one or the bottom one? I mean, I'm going to tell you there's no wrong answer. You could plug it into either of them. Which one, just eyeballing it, which one looks easier? Why does that one look easier to you? There's a lot less going on. I agree with that completely. There is less going on. First of all, aren't there less negatives? Always a good thing, right? Plus, doesn't it already say y equals? And isn't y the letter we're trying to find? Yeah, so we're going to take this and we're going to plug it in where we see x here. Because we know that x is 0. We're going to plug it in where we see x. Okay, and this is going to be the last thing that we do. And then next class, we're going to do some kind of activity, I think, to help us understand this better. And then try out a few more examples, okay? So when we plug this in here, we're going to rewrite our equation. We have y equals negative 4x plus 4. Which letter are we plugging something in for? The x, right? So we're going to rewrite this as y equals negative 4, put your parentheses, plus 4. What number are we plugging into those parentheses, Olivia? 0. And now follow your order of operations. What's negative 4 times 0? Anything times 0, Annalise, is 0. You're thinking like times 1. So that's 0 plus 4. And what's 0 plus 4? 4. And then how can I write my final answer as a coordinate point? 0, 4. Okay.